Hello again, you absolute legends. I'm Eric J. Choi, and I'm going to be explaining Section 5 Explainer Video 2.2, which talks about a container with water spewing out of it, which uses Bernoulli's law. And cue. Okay, jumping right into the problem. A water tank of height h has a small hole at height y. The water is replenished at the top to keep h from changing, and the water squirting from the hole has a range x. The range approaches 0 as y approaches 0 because the water squirts right onto the ground, and the range also approaches 0 as y approaches h because horizontal velocity becomes 0. Thus, there must be some height y between 0 and h for which the range is a maximum. Note that the professor actually provided the answer to B because he thought the problem was too long, which I'm very grateful for. So all we have to solve is A and C. So we're looking for the flow speed V with which water exits the hole at height y, and the maximum range x max, and also the actual height y of the hole. And right here is the provided answer for B. And judging by the description of the problem, this is what I imagine the diagram looks like. A container that has a hole at some height y that shoots out water that goes up to a range x, with the actual container's height being h, and the top is staying stagnant, or the water level is not changing because it's constantly being refilled by an unknown source. Now, when it comes to height, pressure, and velocity of a fluid, the best thing to use is Bernoulli's equation. So, the 2 points that I use for Bernoulli's equation is the top of the container and the point where water flows out. Now note, for point 1, it's stagnant because it's not going up or down because it's constantly getting refilled as water flows out. So the actual V for point 1 is 0. And since both of these points are exposed to the air, that means the pressure for P1 and pressure for P2 are equal to each other, or rather just P atmosphere. Now if we plug all of those noted values into our equation right here, we end up something like this. PA is equal to 1/2 PA, 0 makes it cancel out. PA GY is equal to PA plus 1/2 PA V2 squared plus PA GY2. Now you might notice that Y1, I didn't replace it earlier, but it's simply just H, and every single part of the equation has PA, so that can be divided out. And once you simplify everything, it ends up looking like this. What we're looking for is V2. So this one right here. So we're trying to isolate that out, moving everything to the other side, and then dividing out 1/2, and then square rooting the other side, which leaves us with this equation, 2gh minus y. And using our reference from B, which this is the answer for x, to find the max x range, we first have to complete this equation right here by plugging in this v value that we got right here. So by adding this into the equation, we end up with an equation that looks like this. And after some math, we end up with x is equal to the square root of 4y times the quantity h minus y. Now, this is a general equation, but if you brush up on your calculus skills, you might realize that to find the max, we have to actually differentiate the whole entire equation and set it to 0, which is done right here. I'm pretty sure I don't have to explain how to differentiate, but once you finish that, you divide this out to 0, and that disappears, and you're ended up with 4h minus 8y. You isolate out the y for a final answer of h over 2. Now, we already had an x max equation, so once you plug in h over 2 into the equation that we had before, so plug in that for y here and y here, we end up with something that looks like this. 4 times h over 2 times the quantity h minus h over 2, which ends up simplifying nicely to exactly h as our final answer for x max. Thank you for watching, you absolute legends.